the actual handout here. So how are 2 to the x and log base 2 of x related to each other? Well, let's take this one and rearrange it. If I rearrange it, the b is 2, the c is y, and the a is x. So what I'm really asking is, how is y equals 2 to the x related to x equals 2 to the y? Well, you can tell right here they're inverses because the x's and y's are switched. So really what that means is, another way of saying this is this. So y equals 2 to the x and y equals log base 2 of x are inverses. Okay, let's graph 3 to the x. So here's our table. It's a parent function. Y equals 3 to the x, negative 2, negative 1, 0, 1, 2. 3 to the negative 2 is 1/9. 3 to the negative 1 is 1/3. Then 1, then 3, then 9. The asymptote, it's a parent function. So that's just going to be y equals 0. Domain is all real numbers. Range is going to be y is greater than 0. And then what we need now is just to graph it. Okay, so let's graph it. So negative 1, negative 2, 1, 2, and then all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our asymptote is y equals 0. And then we've got some points here. Negative 2, 1/9 is just right there. Negative 1, 1/3 is a little bit higher. 0, 1 is right here. 1, 3 right there. 2, 9 way up here. And there's our graph. And then the y-intercept is this guy right here, 0, 1. Okay, now let's graph the inverse. Right? Well, here's the original chart right here. Right, so I'm just going to cut and paste that. Edit, cut, or actually, let me just copy it. Copy, paste. Okay, this is for y equals 3 to the x. If I want if I want the inverse of y equals 3 to the x, well, that chart just switches all the x's and y values. So instead of negative 2, 1/9, I have 1/9, 2. Instead of negative 1, 1/3, I have 1/3, negative 1. I've got 1, 0, 3, 1, 9, 2. Instead of y equals 0, I've got x equals 0. And then domain and range, they switch when you go to inverses, because domains are x values. Well, now they were whatever the y values were here, so now it's really x is greater than 0. And the range is going to be, instead of x is all real numbers, now it's y is all real numbers. So then let's graph this. So here's my chart. And let's see here. The asymptote is x equals 0. That's a vertical line right here. Okay, so this is x equals 0. And then I've got, let's see, I go up to 9 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. And up a couple and down a couple. And so I've got 1/9, 2. So 1/9 positive 2 would be about here. And then I've got 1/3 negative 1. Oh, sorry, 1/9 negative 2. 1/9 negative 2 is down here. 1/3 negative 1 would be like here. 1, 0 is right here. 3, 1 is here. And 9, 2 is here. And you can kind of tell that it looks like this shape. Right? So this is the graph of the inverse of y equals 3 to the x. Okay. We also need, oh, the x-intercept, by the way, is 1, 0, because it asked for that. Give the equation for the inverse. Well, the inverse of y equals 3 to the x is x equals 3 to the y. And then we need to rearrange that so we can get y by itself. Well, the way to do that is to use this formula. Log base b of a equals c means the same thing as b to the c equals a. Right? These mean exactly the same thing. So if I line up 3 to the y equals x, and I can rearrange it into my log form. So this is going to turn into, let's see, log base 3 of x equals y, and there's the inverse of this. Okay. Okay, I think I'm still recording. All right, let's take a look at number 4. So in number 4, you're asked to graph log base 1/3 of x, and you want to use the inverse to help. So the first thing you want to do is figure out what the inverse is. So the inverse is going to be x equals log base 1/3 of y. Well, that's not very helpful. We need to rearrange the form. So I'm going to write log base b of a equals c means the same exact thing as b to the c equals a. So let's rearrange it. B is 1/3. C is the x, and then we have y right here. So the inverse is y equals 1/3 to the x. So over here, I'm just going to write y equals 1/3 to the x and make a chart for the inverse. Well, 1/3 to the x, we know how to graph that. The asymptote is always, it's a parent function, so y equals 0, domain's all real numbers, range is y is greater than 0. The x value is -2, -1, 0, 1, 2. The y values, the reason there's an extra gap here is, well, 1/3 to the -2 is really 3 squared, so that's 9. 1/3 to the -1 is really 3 to the first, so that's 3. 1/3 to the 0 is going to be 1. 1/3 to the first is just 1/3, and then 1/3 squared is 1/9. Well, to get to the original, we need to switch all the x's and y's. Switch x and y. So instead of -2, 9, it's 9, -2. Instead of -1, 3, it's 3, -1. It's 1, 0 here. It's 1/3, 1, and it's 1/9, 2. And instead of y equals 0, that switches to x equals 0. Instead of x being any real number, it's now y is any real number. And instead of y greater than 0, the domain will be x is greater than 0. So then let's look at the graph. We've got a lot of positive x's. And then the y's are -2 to +2. So -1, -2, +1, +2. And then up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's do the asymptote first. So asymptote at x equals 0. So that's right on this axis here. We've got the point 9, -2, which is down here. We've got the point 3, -1 right here. 1, 0. 1/3, 1, like here, and 1/9, 2. So this graph looks like this. Just like that. Okay. Let's do one more. So kind of an uglier one. Graph y equals log base 3 of x plus 2 minus 1. Okay, and it says, again, use the inverse to help. So one more time, I'm going to write log base b of a equals c means the same thing as b to the c equals a. So first, to get the inverse, it's going to be switch the x and y. And then we need to get y by itself somehow. So first I'm going to get log base 3 of y plus 2 by itself. So I'm going to add 1 to both sides. And at this point, now I'm going to rearrange it using this formula over here. So it's log base 3 of y plus 2 equals x plus 1. And if we rearrange that using the same letters in the same places, b is 3, c is x plus 1, and a is y plus 2. So this turns into, this means the same thing as 3 to the x plus 1 equals y plus 2. Okay? And then we need y by itself, so y equals 3 to the x plus 1 minus 2. Well, we know how to graph this. So first we're going to graph the parent function. So this is for the inverse. The parent is y equals 3 to the x. So let's do negative 2, negative 1, 0, 1, 2. 3 to the negative 2 is 1/9. 3 to the negative 1, 1/3. 3 to the 0, 1. 3, 9. The asymptote is y equals 0. Domain is all real numbers. Range is y is greater than 0. And then we've got, let's see, what do we do to get to the second chart? We need to go left 1 unit and down 2 units to get y equals 3 to the x plus 1 minus 2. So that's going to be, let's see, left 1 means subtract 1 from all the x's. And subtract 2 from all the y's, so that'll be negative 1 and 8/9, negative 1 and 2/3. Subtract 2, negative 1, subtract 2, 1, and 7. If we subtract 2 from the y's, then this becomes y equals negative 2. The range becomes y is greater than negative 2. And the domain, if we subtract 1 from all numbers, we still get all numbers. Okay, to get the original, remember this is the inverse. So to get the original, switch x and y. Okay, so now I've got negative 1 and 8/9, negative 3. Negative 1 and 2/3, negative 2. Negative 1, negative 1, 1, 0, 7, 1. If you switch x and y, the asymptote's no longer y equals negative 2, it's x equals negative 2. Instead of y is greater than negative 2, we have a domain of x is greater than negative 2. Instead of the domain being all real numbers, now the range, the y values are all real numbers. So now we can graph it. Let's see here. I'll do a graph kind of like this. So we go out a couple, and then up 7 on the x. 1, 2, 3, 4, 5, 6, 7. And then up a couple here and down at least 3 here. 1, 2. And so the asymptote's x equals negative 2. That's right here. One of the points is almost negative 2, negative 3. So right about there. Negative 1 and 2/3 would be, and then that goes with negative 2 about here. Whoops. Negative 1, 1's right here. 1, 0's right here. 7, 1 is right there. So you can kind of tell this picture does, or this graph does something like that. So this is the graph of the original, which was y equals log base 3 of x plus 2 minus 1. Okay. Now, if you get stuck trying to remember how to do this, if you look on the next page on your handout, it's a step-by-step guide on how to graph logs. It reminds you, okay, find the inverse and get the y equals in the inverse, and it should be something that looks like this. Well, you know how to graph those things, so make the table and then switch the x's and y's and graph what you get as a result, and that's the original instead. Okay, hope this helps some.